Okay, so now we're going to continue with our little mathy stuff that we're doing. Okay, and we're going to talk about density. Now, chances are you've talked about density before. Okay, and we're going to talk about it a little bit more because density is a pretty important concept. All right, density is actually a way of identifying a substance. Right, so it's a really important idea. So, density, as you've probably heard before, is the mass per unit volume. Or, mathematically speaking, density equals the mass divided by the volume. Okay, now, the units for density are a derived unit. Remember, derived unit means whatever mass you divided by whatever volume, that's your unit of density. So you could have grams per milliliter. That's a common unit of density. You could have pounds per gallon. That's a unit of density. It's a mass and a volume, right? So the unit for density is always a derived unit. Okay, so let's look at a couple examples. All right, says what is the density of a 5.40 kilogram stone if it has a volume of 1020 milliliters in units of grams per milliliter? I want my density in units of grams per milliliter. So I have milliliters right here, but here I have kilograms. So the first thing I've got to do is I've got to change kilograms to grams. Okay, so I'm going to set up my Duflachi. 5.40 kilograms, grams. Because this is a metric conversion, kilo is going to go up here, 1,000, gram is going to go down there. I have 1,000 times 5.40. Now, careful, because here we could just write 5,400, but what's wrong with that? Well, that only has two significant digits. So really, the best way to write this is 5.4 times 10 to the third grams divided by 1,020 milliliters. That gives me grams per milliliter. Okay, and then when I divide that out, I get that the density of that stone is 5.29 grams per milliliter. Okay, now here's the thing about density. Density determines whether or not something can float in another substance. Okay, so the density of water, this is important to know, is 1.0 grams per milliliter. That's convenient, isn't it? Okay, the density of water is 1.0 grams per milliliter. So, would this float in this? It would not, because the density of this is higher than the density of water. Okay, and therefore it will not float. Okay, it can't displace enough water to make it float. Okay, so that's how you determine whether or not something will float, is if its density is less than the density of the substance you put it in, it's going to float. If it's greater, it's going to sink. Okay, so what's the mass of a block of aluminum with a density of 2.70 grams per milliliter if you immerse the block in 165 milliliters of water and the water level rises to 193 milliliters? Okay, so density equals mass over volume. All right. Now, here I have the density, right? What am I trying to find? I'm trying to find the mass. So let's rewrite this equation and say that mass equals density times volume. Okay? So density, 2.70 grams per milliliter, times my volume. Well, I've got two volumes here. I've got 165 milliliters and 193 milliliters. Okay, which one is it? It's neither. Okay, because what's happening here is I have water at 165 milliliters. I put my piece of aluminum into the water, and now the water comes up to 193 milliliters. Okay, so what made the difference in the water? The aluminum did. So the mass of, or the volume of the aluminum is the difference in the volume of the water. This is called measuring by water displacement. Okay, If you have an irregularly shaped object, right, often that's the way that you'll find the volume of it, is you'll put it into water and see how much the water level rises. Okay, and so when we do that, we get that we have 28.0 significant digits, milliliters. Okay, grams per milliliter times milliliters. Milliliters cancels and leaves you with grams. And the mass is 75.6 grams, rounded to 3 significant digits. Okay, so that's your units are key here. Okay, if you haven't noticed, that's kind of a theme for the year. The units are key. All right. You have to match up the units to what you want. All right. Let's look at another one. Student wants to identify the main component in a commercial liquid cleaner. She finds that 35.8 milliliters. The cleaner weighs 28.1 grams, which is the main component of the cleaner. Remember, I said that density is an identifying property. Okay. Density is called an intensive property. It does not matter how much of the stuff you have, the density is always the same. Okay, that's what an intensive property is. Okay, the density is a characteristic of the substance. So if we find the density of this substance and compare it to the density of these 4 substances, all right, that should tell us which substance it is. So density equals mass over volume. Mass is 35.8 grams. Volume is 28.1. Oh, no, I did that backwards. Sorry. Look at that. Look at that. Chemistry teacher. Mass is 28.1 grams. Volume is 35.8 milliliters. Wait a minute. But what unit am I trying to get? I'm trying to get grams per cubic centimeter. Well, here you go. I'll give you a little conversion. All right. This is an important conversion, and it's really hard. Okay. 1 milliliter, it's hard to remember, equals 1 cubic centimeter. Ooh. So 35.8 milliliters is how many cubic centimeters? Well, it's 35.8. Okay. A milliliter and a cubic centimeter are the same thing. So when you divide this, what you get is you get 0.785, 3 significant digits, grams per cubic centimeter. Okay? And so the main component of that liquid is isopropyl alcohol. All right? So density is a characteristic of the liquid. It is an identifying characteristic. All right? Isopropyl alcohol has a density of 0.785 grams per milliliter, which we just saw. What volume should be measured to obtain 20 grams of the liquid? Okay, we got to be careful on this one. This one tricks students all the time. All right? So, density equals mass over volume. What are we trying to find? We're trying to find the volume, right? So, here's what people do. Like, oh, well, I just need to divide by mass and get density over mass, and that's my volume. No, that's 1 over the volume. Okay, that's not what you're trying to find. Okay, you're trying to find volume. So what you need to do is say that volume times density equals mass, and volume equals mass over density. Okay, it's exactly the opposite of what your mind tells you you need to do. When that variable is in the denominator, you gotta be careful with it. Okay, so if volume is mass over density, got 20 grams is your mass, 0.785 grams per milliliter is your density. Okay, and so when you solve that, you get your volume of 25.5 milliliters. All right, so this is density, okay? And this is very important, a very important property to be able to measure.